Pleasant morning to one and all. I'm Dr. Sumitra, an associate professor from the Department of Computer Science and Engineering. Today, our students will all discuss about how the DT-based CPE schedule will be carried out. Thank you.
Hello everyone, let us see about CPU scheduling. First, a quick introduction. CPU scheduling is a fundamental concept in operating systems that determine the order in which processes execute on the CPU. Since multiple processes compete for CPU time, an efficient scheduling algorithm ensures optimal performance, responsiveness, and resource utilization. Scheduling decisions impact system efficiency, affecting factors like throughput, turnaround time, and CPU utilization. Various scheduling algorithms such as first come first serve, shortest job first, round robin, and priority scheduling are used depending on the system.
Round robin is one of the most widest used CPU scheduling algorithm in operating system. It is primitive scheduling algorithm that ensures fairness among the process by allocating a fixed time slice known as time quantum to each process is ready queue. If a process does not complete within the allocated time, it's primitive and move to the end of the queue. Working of round robin scheduling. Process queue formation. All processes are placed in queues in order they arrive. Time quantum allocation. Each process gets CPU access for a fixed time quantum. Process execution. If a process finishes within a time quantum, it exits the queue. If not, the primitive move to the end of the queue. Continuous execution. The CPU cycles through the process repeatedly until all processes are completed. Advantages of round robin scheduling. Fairness. Every process gets equal CPU timing. Avoids stagnation. No process is responsive suitable for interactive system. Disadvantages of round robin scheduling. High content switching overhead. Frequently switching reduces CPU effectively. Inefficient for long time process. Short process may wait longer. Performance depends upon the quantum. Too small, increase content switching overhead. Too large, becomes similar to first come, first serve. Application of round robin scheduling. Time sharing systems like operating system. Network scheduling for broadband distribution. Multitasking environment for balancing CPU operation. Thank you.
Long-term scheduling. Long-term scheduling is responsible for selecting processes from a pool of submitted jobs and loading them into ready queue for execution. It controls ensuring that the system does not become overloaded. By the limit to the process of active, if too many processes are loaded into memory, the system may become slow and inefficient due to excessive content. Switching and resource contention. On the other hand, if too few processes are admitted, system resources may remain unutilized. The long-term scheduler ensures a balanced mix of CPU bound and IO bound processes to maintain optimal system performance. CPU bound processes requires more CPU processing time, while bound processes spend most of their time waiting in input or output operations. By carefully selecting process, the long-term scheduler prevents system and enhances efficiency. This type of scheduling is primarily used in batch processing system where jobs are executed in sequence without requiring immediate user interaction. However, it is not commonly used in interactive and time-sharing systems where processes must respond quickly to.
First step, this is the simplest scheduling method. Tasks are proceeded in the order they arrive. Example, a student submitting an assignment first will have their file processed before others. Where it's used, ideal for non-urgent tasks such as batch processing of student submission. Advantages, easy to implement, fair for sequential tasks. Disadvantages, long waiting times for later requests, not suitable for time sensitivity operation like live.
Short-term scheduling, CPU scheduling. Short-term scheduling, also known as CPU scheduling, is responsible for selecting a process from the ready queue and allocating CPU time to it. This is the most crucial type of scheduling as it occurs frequently, often every few milliseconds. The short-term scheduler determines which process should run next whenever the CPU becomes idle, ensuring efficient CPU utilization. Since CPU time is a valuable resource, an effective scheduling algorithm must minimize waiting time and maximize throughput. Various CPU scheduling algorithms are used to determine the order in which processes execute. The choice of algorithm depends on factors such as fairness, response time, throughput, and system type, batch, interactive, or real time. The primary advantage of short term scheduling is that it ensures that all processes receive CPU time based on predefined scheduling policies. This leads to improved CPU utilization and better responsiveness, especially in time sharing and in interactive systems. However, one of its major disadvantages is the high overhead associated with frequent context switching, since short term scheduling decisions occur at a very high frequency. The system must perform numerous context switches, which can degrade performance. Additionally, a poorly designed short term scheduler can lead a high waiting times for certain processes, negatively affecting system efficiency. Another issue is stagnation, where lower priority processes may never get CPU time if higher priority processes continuously arrive. To address this, some scheduling algorithms incorporate aging techniques to gradually increase the priority of long waiting processes, ensuring that no process is indefinitely delayed.
So, in summary, CPU scheduling plays a crucial role in managing system performance and resource allocation. By selecting appropriate scheduling algorithms, operating systems can optimize process execution, reduce waiting time, and enhance overall efficiency. Different scheduling methods have their own advantages and trade offs, making it essential to choose the right approach based on system needs. Effective CPU scheduling ensures smooth multitasking, better CPU utilization, and an improved user experience. Thank you.